Good morning. My name is David Loveluck. My role at InterSystems is to concern myself with the performance of applications. And there are a lot of people in InterSystems who look at the performance of systems, who are looking at the CPU usage, looking at architecture of I/O subsystems, but my role is really to look at applications from the application's point of view. And what I want to talk about today is application performance management. I want to give you an overview of what APM is. I want to look at some of the tools that can be used from within Cache, Ensemble, and InterSystems Iris to look at the performance of applications. And then I want to take a case study of a real site that I looked at over the summer to come up with a performance report for the customer. And I'll very quickly go over that. There's a lot of information I want to get across today. There's more information in the slides than I'm going to talk about today, so I'm going to skip over some of the slides. The information's in there for completeness for people looking back at the presentation after the event. So what is application performance management? It's an area that's been discussed for many, many years, and sometimes it's actually given a title, and some people just think about it as looking at the application of the performance of applications. To me, it's very simple. It's just looking at the performance from the application's point of view. How much is the application used? How much are the different components of the application used? And by component of the application, that's one of the key issues. The crux of the matter is understanding what is a component of an application, what is a transaction within the application. You want to look at how well those individual components perform, how much resources each component uses, and then build up a report on this. It's not just monitoring, it's not just performance monitoring, it's a systematic process for measuring, reporting, and improving the application. I said there are lots of people in InterSystems who've been looking at the system-level performance for many years, and obviously individual developers are very concerned about the performance of the application code they write, but this is to systematically look at that. What I've been doing is very complementary to the system-level performance. You can't, if you look at the application performance and you're continually striving to improve the performance of the application, that doesn't mean you don't have to worry about the I/O subsystem and making sure that it's well designed and balanced and capable of doing the job it's asked to do. There's an industry of APM tools out there. These vary from JavaScript injection, web robots monitoring the end-user application, the end-user experience. There's instrumentation in middleware tools. There are tools for analyzing the runtime architecture. And by the runtime architecture in this context, what I mean is for a complicated application, what actually happens when the user hits the enter button or clicks or touches a touch screen, what actually happens behind the scenes, because it's very unlikely in today's applications that it's just going to go to an application and come back again. It's probably going to go to some middleware layer, it's going to go to a web server, it may well send out a request to a service-oriented architecture thing, it may well be querying a database, you may have microservices involved, you may involve many different servers just to satisfy a simple click of the mouse. And to understand where that request has gone and how much resources are used in each of those services and how long each take is critical to understanding the overall performance of that application. There's instrumentation into all sorts of protocols, and there's also a set of tools, different ways of taking the information that you get, bringing it back and giving you a visualization of that data. There are a lot of tools out there. I'm not going to talk about any of the commercial tools. I'm just going to focus on some of the things we've got in the InterSystems technology today. But there are tools out there to make sense of all this and give you graphical rendition of visualization of where all that time was spent and things. I use a spreadsheet personally, but that's okay. I'm old-fashioned. I'm a dinosaur. I've been using spreadsheets since way before Excel. Because there's this industry out there, of course Gartner weighs in, they've got their conceptual model, they've got a conceptual framework with 5 components, 5 dimensions to it. Again, they focus on the end-user experience, they focus on the ability to track where that application is going, they focus on breaking the application down into meaningful transactions that the end user understands, and the deep dive analysis, so when you actually get to the point where you know where the resources are going, you've got to have a deep dive analysis to understand why it's going there. And I'm going to be mentioning some of the tools in our technology that correspond to that, and again, they focus on the reporting. To me, however, I think if you start with focusing on the customer, you're on the right path. Focus on the customer. And by customer, in this context, it's not the system admin person, it's not the techie who's installing the software, it's the person who's putting fingers to keyboard, using the application, and the other important customer is the person who's paying the check, the line of business owner who owns the application. You need to understand how the customer measures business. How busy is the system? How much business is being used by that system? What do the users actually do? What's the activity count for the users, the resources used in those? And then you've got to build a historical record of that. It's an important part of the process is to build a historical record. I've got a teenage son, and he is addicted to watching the TV show Mythbusters. Does anyone watch Mythbusters? Yeah, it's a great show. They've got these zany guys who do zany things, and it involves an awful lot of explosions, but it involves a little bit of engineering and things. And my son was really taken by this quote that one of the guys came up with as they were trying to blow something up, I can't remember what. Oh, they were trying to implode something. And he said, the only difference between screwing around and science is that with science, you write it down. And I think that's absolutely essential here, is understanding that if you go deep down and you do all this analysis and you pore over detailed sheets and come up and say, right, now I understand where that resources are going, if you don't write it down, if you don't write a historical record, you're just screwing around. You're not being productive in the long run. Because if you just write down basic stuff, you're going to be given. Because once you write it down, you can do things like report over time. And I'm going to come back to this graph later. You can compare across components. You can compare across sites. Site A is doing this and site B is doing something else. But you can only do that when you've got that historical record. And the final part of APM is really that deep dive analysis in the engineering team that makes this a cycle. This is why it's not just monitoring, it's the systematic process where the goal is systematic improvement of the application performance. You get the data to the application designers, you understand what's causing the performance problems or where the resources are going, and where the resources are going, and you use the low-level tools to actually understand this stuff and feed that back into the engineering process in a systematic way, so that you're not just reacting to a customer crisis where somebody says, this screen's taking 10 seconds to load, it's impossible to use, and suddenly you've got engineers working at 2 in the morning trying to put a Band-Aid on a problem and try to come up with some easy fix, a quick fix. Maybe they'll buy some more CPU power or put in an extra disk, but basically they're working at 2 in the morning trying to fix a customer crisis. And this is a systematic process is to avoid that happening. I guess it's true for anything, but I think in performance monitoring, understanding the audience is vitally important. I mean, it's true for any information. If you're going to get a report, you're going to give information to somebody, and understanding who you're giving that information to and what they want that information for is obviously really important. But people very often seem to skip that step when it comes to performance tools. They think, well, I've got all these complicated things. You can use CStat and MGStat and P buttons and all these other tools, and that's how, it's all great stuff, and we can get down to the detail. But it's not like that. And I tend to identify 5 distinct audiences for performance information, and the information's got to be given at the right level for those people and in the right way for those people and at the right time for those people. And you could probably argue that some of these are the same, there's blurs where the lines are. But I'd say the operational staff tend not to worry much about technical details. They just want a simple answer. Is there a problem? Is there not a problem? They don't really want low-level tools where they've got to type stuff in and come up with graphs. They want a flashing red light that says, there's a problem, call someone. The technical staff are asking, how do I fix the problem? I've just been told by the operations staff, or less ideally, they've just got to be shouted at over the telephone by the manager of the people using the system that the system's unusably slow. But either way, the technical staff knows they've got a problem and they're trying to fix it. And that technical staff could be the end users, the technical people at the end user at the customer site. It could be the people building the application. It could be the InterSystems support staff. It could be me. And if if a problem comes to us, I mean, we obviously have vendors as well that we work with. Maybe we're talking to IBM about what the problem is. But there's that chain of technical people. And those people are willing to spend a lot more time understanding the application, understanding the technology, using complicated tools. And that's fair enough. You're going to sit at a terminal trying to solve a problem and be typing stuff in. Architects, they're building a capacity plan. They probably want much higher level information. They want long-term trends. The executives, their question is, am I getting my money's worth? I'm paying $1 million a year for this application. What am I getting for it? Am I getting the right level of service? And they don't want any technical mumbo-jumbo. That's what they want. And then the fifth person is the application designer, which is, again, I'm going to emphasize this closed circle where the information is getting back to the designers of the application on a systematic basis, not just at crisis time. And they're looking for things. So how do these people use that historical record I was emphasizing so much? Well, the operational staff don't use, no, they don't care. I mean, they remember the red light came on once before and they called up somebody else and they did something and they fixed it. The technical staff are absolutely dependent on that historical record. How many people here have been in the situation where they're trying to solve a performance problem and the first thing they said is, the first question you ask is, when did it start? And nobody knows the answer. What was the performance last week? Okay. Well, it's doing 2,000 global references today when it's really slow. How many global references did it do last week when it was okay? I don't know. So without that historical record and the systematic process, you're guessing. The architects, and they're predicting the future built on history. If somebody's, if the architect is trying to put together a capacity plan and the CMO says, we are going to add new outpatient, non-critical outpatient facilities that's going to increase the number of outpatient episodes by 30% in December. What hardware do we need? How many, 30%? Well, how much have we been doing in the last year? How much were we doing the year before? How much does the outpatient episodes contribute to the overall load in the system? And the executives don't really worry about history reports so much. I mean, here, I'm really going to suggest that imagine the executive who's responsible for the application has a quarterly status meeting, and you are given the great privilege of reporting on the performance of the application. You've got 10 minutes, just before lunch. And your job is to tell the executive how much the application's used, how much resources are being used, how those two things have changed, what performance issues you have, and what the plan is to address those performance issues. You've got 10 minutes to sum that up. And the trouble is, you can put on some nice pretty slides, but 3 months from now, you're going to have to do it again. And this time, the first thought in whoever's doing the status review is going to be, last time you said you had 3 performance issues and you had a plan to fix it. What have you done? And if you haven't done anything, if you can't prove that you've done something, you're going to have an uncomfortable 10 minutes. But if you can prove that you've done it, and if you say, look, we did this, we implemented it, the problem was resolved, well done, pay rise. Nice. And the application designers really here, that historical record is to focus research and development effort where it's needed. That is, you address the problem issues, you address the issues that are most heavily used. You're not just addressing here's a screen that's slow, but it's only used twice a month. Well, who cares if it takes 10 seconds twice a month? This one takes 0.8 seconds, but it's used 35,000 times a day. You've got to know where that R&D effort is going to go. Got to focus on the important things and also identify trends before they become significant issues. So that's the historical record. And that's really what I see application performance management is. It's that process of gathering information, identifying the business transactions, identifying things. And now I want to switch gears slightly and look at some of the tools that we've got in InterSystems technology to help you do that. I'll talk about what ideally they do, and unfortunately none of the tools I'm going to talk about actually live up to this entirely. So it's not an ideal situation, but we're working to improve that. And part of my role is to specify the improvements that we've got to make in those tools. The first important thing is the tools have got to be safe, easy, and intuitive, or relevant. They mustn't slow the system down, and they mustn't fill the disk. You don't want to turn on tools and come back 6 months later and find out you've got 500 gigabytes of disk space being backed up every night full of performance information that nobody's ever going to look at because it should have been summarized and rolled up into nice small things. It's got to be easy to set up and leave running. If for some reason, maybe it's a little bit too expensive, maybe it does use disk space, you can't leave it running permanently, you just turn it on for a week and then turn it off again. It's got to be easy to turn on and off. It's got to be easy to export the results. And I actually mean export. I don't just mean it's got to be easy to look at the results, to run some SQL against it. It's got to be easy to export, because one of the key parts of this process is to get it back to the engineers, to pour over that information, to consolidate from multiple sites back to a central facility so that the vendor of the application can work on it and get that information back in-house. So just saying, well, we've got some charts and some dashboards and you can look at a pretty graph, that's not enough. You've really got to have those export capabilities to send that information back. And it's got to be relevant. If you show it to the customer, they've got to know what it means. There's no, if you look at some of the low-lying tools in Cache, at MGStat, if you showed that to a business person at a hospital, they're going to look at it and it's just nonsense. It's gobbledygook. It doesn't mean it's useless, but it's not meaningful to those people, the end-user customers. Ideally, you build the measurement into the application. You put measurement hooks per transaction, per screen, per report, per batch job, whatever is relevant to the application you're building, designing, and installing and selling to a customer. Nightly reports should be gathering information into a similar nice, easy, queryable format, rolling up those daily details, those transactional details maybe, looking at important business metrics, maybe running some SQL queries to identify the number of hotel rooms booked today, the number of widgets sold today, the number of inpatient episodes, the number of outpatient episodes, the sort of thing that you can quantify by running SQL against the application database and saying, yeah, this is what we've done today. And not all customers are non-technical. Some customers are technical. For example, if you're buying Health Connect as an HL7 interface engine, then you are technical, but your unit of business is the HL7 message. Not, you're not talking, they aren't thinking in terms of patients admitted. Ultimately, in the big scheme of things in the hospital, it's patients admitted, but to the person who's the director of integration, they think in terms of HL7 messages per day. And it's then good to report back, to roll those things up, so you can actually then get reports on that are relevant to the application. So it's a usage per business metric. When that is, disk space per inpatient episode, journal space per HL7 message. If you're selling widgets, then it's how many global references were taken per widget sold. Now, that's what I think an APM tool ought to be able to have, something that's going to measure this information. But I'll look at some of the generic tools that are in Cache today, or Ensemble today. They're not all, some of these are Ensemble specific, and talk about what they can be used for, what they can't be used for, and how they live up to those targeted goals. I'm going to skip over some of the screens. There are screens in here for how to set it up, and I don't want to spend time explaining those at that level, but I've included them in the slides. CSP Gateway statistics. Anyone use the CSP Gateway statistics? Okay. These record for every CSP request going through the CSP Gateway, which includes all the web, HTML pages. It includes CSP, REST, Zen, SOAP requests. All go through there. It records the URL. It can record the timings, and it can include the size of the input and the output. So you turn it on through the management portal, and you can actually filter it so that it only captures information for things that take longer than 0.1 seconds or 5 seconds, so you don't fill up the file with lots of information that is about these really tiny, quick things. Everything goes into a flat file log, which gets rolled over every now and again, And various people have written tools to analyze these things. Various sales engineers support people who have written tools to do these things, but there's nothing actually in the product to do that. And as I say, you can turn the trace on through the management portal, and it ends up in a flat file. There you can see it says post track dev CSP broker, and it's got the total time of service. And I put 0.5 seconds as the cutoff, so this is only limiting something that's got 0.604 seconds shows up, nothing less than half a second shows up. What's good about these? The URL is often closely related to user activity. Not always. I mean, if you've got some sort of container page that does all the work, as some applications do, then the URL is always the same. There's something about in the URL that but you can't see from the page name what the customer is actually doing. But often it is a good thing. And the timing information, performance activity is good. It's easy to turn on and off, very easy to turn on and off. What's not so good is there's no other resource usage. It's just the timing because it's in the CSP Gateway. It's not in the cache server. It's just a continuous stream of information to a flat file with no analysis tools. It will fill up disk space eventually if you don't set up a process for purging those files. And so I'd say in conclusion that it's good for investigating specific problems, but I wouldn't use it for continuous monitoring. You'd have to invest too much in getting that information. There are probably better ways of doing it. CSP page statistics, these come from the other side. These come from the CSP server. And again, they come from the %csp.page, so that includes REST and SOAP. It's not just HTML pages. And for every page gathered, it takes the lines of code executed because of the global references and aggregates them all into a global. And so it works for SOAP and request. This is controlled by a class parameter, either in the class itself for the web page or in a superclass. So you can set those classes, you can set it higher up if you want to. And there are two parameters. Page timing is just an on-off switch, and timing slots gives you a number of slots in the day, so you can break this down. That's not for a full day. It defaults to 40, I think. Here I've just increased it. And when you compile the page, it puts these start timers, stop timers into the web page. It's pretty lightweight, and then it puts it into, and so for this page in the timing window, you'll get 6 entries, which is the total number of globals and lines and time and everything, and you can do your analysis on there. And you'll get one of those 6 entries for every page executed for every time slot. So the page name, page names often related to user activity, so you can take it from that point of view. Excellent statistics, very lightweight. Well, it's lightweight. I would say very lightweight, because you've always got to be careful. And it's aggregated directly into a persistent global. So it doesn't fill up disk space. I mean, obviously it takes disk space, but it's not writing every single transaction out to a file in one big go, filling up megabytes and megabytes and megabytes. What's not so good? It's hard to turn on at a customer site. To turn it on, you've got to go and set that class parameter, which means editing the class and recompiling. And I don't know how you feel about your customers. If you're an application vendor, I don't know how you feel about recompiling classes and editing classes on customer sites. No. No. And you can see people shaking heads. The results, while they go into this global, which is really nice, they're not visible to SQL. There's no SQL mapping on that global. You could map that to global, or you could write your own code to just pull it out and put it into tables the way you want it. Nobody's just done that. And there's no automatic roll-up to longer periods. So I'd say in conclusion for this, I'd say it's excellent for all but the fastest services. If you've got a REST-based service that is just doing something that's taking a millisecond and you're doing 4,000 of those a second across your multiple cores, this might add a significant overhead. For most applications, it's probably just fine. And you can't easily turn it on the customer site, so application developers, designers have to think about it before they ship the product. Now, if that's an internal application, it's easier, but if you're shipping it to 100 different customers, then you've got to think about it in advance, and it's a design decision because you're going to end up with this data being collected, and you've got to make sure, A, it's not going to take up more resources than you want to be taken up, it's not going to slow anything down, you've got to have a process in place for that information to be purged, or you've got to put in place tools to report and gather that up and then get it back into an easily used system. The SQL query statistics. This is moving a little bit further away from, it's moving a little bit further away from recognizable end user activities. A lot of applications, it's very easy to associate particular SQL queries with a particular report. You can see that it's in this page, it's a report, it does this query. A lot of applications, that pretty much defines what that page does or what that report does. But in other cases, it's very, very distant. It's good. It does fulfill that role where the designers, the tech people, are trying to understand issues, can relate this query is part of that page, it took 0.4 seconds last week, it's taking 1.2 seconds this week. Is that why everything slowed down? So that does give you that historical record for analysis, but it's hard to present this to, you get anything out of this that you can show to an executive in his quarterly status meeting. There are two-level switch controls. There's at one level it includes hooks, different to the CSP hook code, but it's broadly similar concept. So that every query has the implementation in it, and then there's a second level to actually activate those hooks so it's collecting data. If it has been activated, then it puts the query is put in one table, and the statistics associated with it are added to another table. Every time it's executed, it puts a row into that table. Turned on through the management portal. There's a nice page here going through the tools, SQL performance tools, and runtime statistics. And then you can run a report and get, this query text had 2 hits. You see, this is on my system. This is not a production system. This is my laptop. I've deliberately kept it very, very simple. Select star from drl.league where naming like question mark, hits 2, global references 32. On a live system, these numbers would be a lot larger. And that's just the query for completeness that I ran to get that report. Every time you run these queries, it's going to take CPU to gather the information, and it's going to have at least one database write to put that table in. For a BI application that's joining multiple tables and trawling through millions of rows, that's nothing. But there are some applications that do millions of SQL queries a day. Even on a single page, they can do thousands. For example, this is a screen from one application where each one of these cells is a result, and to get that result, there's a query that's generating the tooltip, the hover text. There's queries to turn, there might be queries to turn an internal tool into milligrams or milliliters. There are SQL queries that will say this is abnormal, outside reference range. So every single cell on that generates multiple queries, SQL queries, and to display this page can take hundreds and hundreds and hundreds of SQL queries. Your application is the only one that you need to worry about. You've got to find out, well, does my application? If you're doing less than about 5,000 queries per second, the cost of having those hooks in there is probably insignificant. If you're doing less than 500, the cost of collecting the data is probably insignificant. Don't quote me on that. Don't say, Dave, I'm only doing 499, and Dave said 500 would be fine, but it suddenly slowed my system down. If you're at 69.99% busy, and it pushes you up to 70% busy on your CPU. So what's good about this? Excellent statistics for measuring queries. It's easy to turn on and off for dynamic SQL. Low cost embedding hooks. What's not so good is it can be expensive, and there's no roll-up or purge for this data, so you have to do that yourself. And for anything that's embedded in class, like a class query or embedded SQL, those hooks, the first level hooks, have to be on at compile time. And again, we're back to the same problems we have with CSP pages. That's got to be done at when you're building your application before it gets shipped to the customer site, because you don't want customers setting switches and recompiling. The statistics, just as a weird one, the statistics are deleted when the query is deleted. Well, you don't go around deleting queries, they're embedded in the code, but by deleting query, if you recompile the code, the first thing that happens is that query, as our internal definition of it, is removed, all the statistics go. If you purge cache queries, the query goes, all the statistics go. So you've got to write some utility to periodically remove that and put it into some nice SQL-friendly environment. It's excellent. These got excellent statistics, but care and investments needed to run them continuously, and you've got to think about it in advance so that you can do this at home. The Ensemble Activity Monitor is added 16.1. This, I'd say, is the closest we have to the fitting the first bill. It's not just that I designed it. I designed it having analysed all these other things and knew exactly what we ought to have. And so basically, this records in a nice global way of, for every inbound message, for example, the time taken in the business service to execute it is added up. So you get a count on the number and the time per business service, inbound, outbound, and they're all rolled up into short windows which get aggregated to a daily statistics. We do provide a sample deep sea dashboard, but really the intent here is the data is made SQL friendly. Point your favorite reporting tool at it and have fun finding out what it wants. We're not going to be in the business of giving you all sorts of dashboards and reports. It's SQL friendly, SQL is available, write your own reports. I was going to say something about visual trace, and I was going to say something about visual trace in Ensemble related to that runtime architecture analysis, understanding where these reports, where the information is going, but I'm going to run out of time, so I'll skip over that. There's a sample deep sea dashboard. As you can see on the left, it's got what we're wearing. You can see these nice little graphs and charts showing how many we have. It's got good counts and timers. It's very low in terms of computer resources. What's not so good, you have to have add a business operation to the production before it can be turned on. That's what centralizes the data. And you can actually have, if you've got 100 servers running Ensemble on 100 different systems, you can all centralize all that data and get it fed into one centralized database. I'd say conclusion for this, that end users consider turning it on today or at your next maintenance window. Similarly, application partners, go home and if you're shipping something that includes Ensemble, it's actually doing messaging and Ensemble production, consider turning it on today and so your next version has it. I think there's nothing really. The Cache History Monitor is not really application performance monitoring, but this is just capturing system level stuff, CPU, global references, system-wide. As I said, the system level information, system performance monitoring is very complementary to the application performance monitoring, and this is a very easy way that not many people know about for turning on and collecting CPU usage, global buffers, total database I/O stuff in a nice, friendly SQL way. People know how to run P buttons, and you get an ARM, a huge amount of data that you've got to pour through and write tools to analyze, or you could just use the history monitor and turn it on if you just go to the documentation and do that. It keeps a nice historic record of system usage information, and it's SQL accessible. It can be run continuously, it's easily turned on, it's SQL accessible. I can't think of anything to say bad about this. I can't think of any negatives, so just start using it. And I've got 10 minutes left, and I just want to talk very quickly about a case study that the application, which will be nameless, but Nathan's one of the development managers. It's TrackCare, obviously. The application framework itself is instrumented, so it captures information right down into there. And each screen is made up of a number of panels. So you've got this information that displays, and each panel is something meaningful to a user. It could be a floor plan, it could be a list of patients, and those are what they're called. It's list EMR, list my patients. They've got meaningful names. And it captures the details about that. It also, it's got a nightly task that captures all the static data that I was describing earlier about what applications, would be really nice if all applications did. The customer was a sized hospital in Europe, and they collected statistics for 6 months, starting in January, and they shipped it to me in June, and I turned around in about 3 days, I turned around a report, nice pretty graphs, colored graphs and charts and lines and things very quickly. And what I've actually now got, I use a spreadsheet for it, and I've got a spreadsheet with about 10 tabs, and I've done this for multiple customers, and the first column, I just have the SQL queries that I want to run against the data. So I import their data, and I go to my query and say, oh, that's the query I want to run, and I run it, and I paste the results into that tab. I go to the next tab. It's a manual process for going from that data to a report, but the charts are all built in there. I'm doing the same one. At some point, I'll get to automate that, but I don't know how to. I like Excel, and I'm not very good at running. I haven't quite figured out how to run the SQL from Excel to pull stuff straight out of the database into those tables. But you'll get there. I'll get there. And we started analyzing the report, and the first thing we did was we pulled up the most expensive components in aggregate. So it was the total number of global references for a busy day, the total number of global time for a global. Just to zoom in so you can see one of those, list Cyto EMR was the busiest, and on this busy day at the end of the window, it was called almost 35,000 times at an average of 1.64 seconds. And it's a bit disingenuous, but if you add that up, somebody is waiting for that screen to come back, or that panel to come back for over a day. So when you put it that way, that's quite a long time. We looked at, another thing we did is we looked at the average response time across the system over time. And we get this steady upward trend. List Cyto EMR, which is that top one, there's still this upward trend. We compared it with different sites. We compared it with this site with another site and found out there's still a lot more global references, but maybe that's not a very good this isn't a very good comparison because it's called a very different number of times on this occasion. We looked at the disk space being used, and we got this, and that's I think anyone who sees that chart will immediately say, it's going in the wrong direction. Now, to be fair to the technical people on the ground, they knew about this issue, they knew what was the underlying cause, but seeing this chart helped focus minds on getting rid of, actually dealing with the issue, and they dealt with the issue on site. And it's also helped focus minds in Sydney and the development organization to make sure that this can't happen at other sites. Why did we let this happen? So what was the outcome? There were a lot more charts and a lot more details, and so what was the outcome? Well, the first outcome was we had a customer report that we could give to the executives at the customer site. It said, here is the current situation on your system, the performance of your system, the usage, etc. And we gave a commitment, 3 months, which is about now actually, 3 months on, we'll get another 3 months of data, and we'll give them an update to that report. That's the equivalent of that executive status summary in their quarterly meeting. The disk space growth issue was resolved, as I said. We took the 10 most expensive items in aggregate back into the lab, and we actually got them to set up a user acceptance testing machine, which I could connect into from my office. And I spent a lot of time using perfmon and monLBL to trace through their work exactly what was going on in their system. They had some expensive icons, they had some other stuff. We found some SQL enhancements. And so of those top 10, we came up with significant performance enhancements to 5 of them, including the top 2. So they have been implemented, they haven't been deployed. I'm a bit nervous, a bit excited about seeing what the results are when those changes do get deployed. I hope it'll change those numbers quite dramatically, but maybe it won't, I don't know. Interesting, the gradual increase in response time has not been explained. We still don't know why that happened. We didn't say, oh, that's because of this. I don't know. Now, if we implement these other changes, those graphs are going to take a kick downwards, but we're going to have to continue watching and see whether that upward trend is still there. So it's continued monitoring needed. So that's a very quick view of that case study about what I want. I'd be happy to talk to anyone at great depth about that, and I've done that for multiple customers, from China, from Australia, and yeah, it's interesting to see different things because different customers have different issues. Some of it's local customization, some of it's the fact that some customers are using some components of the application and others aren't. Different versions, so it all makes a fair amount of difference. So it's a very, very quick tour through some of the tools, what application performance management is, the need for this systematic approach. Where do you go from here? First of all, please complete the survey. Second, you can't go to the tech because that's what I'm supposed to tell you to go. Go to the tech exchange, but that's all packed up. It's about 5 minutes from now, it'll be packed up. You can contact me. I'm Loveluck. My Loveluck at InterSystems. My email. I'd be very happy to talk to anyone who's involved in application performance, either by tuning, systematically implementing your systems, and of course, if you can't remember my email, just talk to your sales engineer. And so that was a very rushed. I apologize for the rush. I had more information than I could get in 45 minutes I wanted to share with you. So any questions?
You have documented anywhere all the different case studies and things you've learned from customers, and maybe perhaps some of these things can be avoided if you have a list of things, good practice, bad practice.
No, is the simple answer. But what I am doing is part of what I'm working on at the moment as a result of this is going to be doing that. I'm halfway through writing a document which goes with this presentation, which is going to be a discussion of these tools, and I'm going to publish that on the developers community, hopefully within the next 2 weeks. The application-specific one about what we can do that came out of those customer studies, that is being worked on, and that information is being spread internal to the people relevant to that application. But so much of this is application-specific. It's not quite so. But so the generic stuff, I'm trying to get stuff written down. I'm trying to get stuff out there, but there's nowhere where it would have, here are everything that you could possibly think, unfortunately.
You mentioned expensive items, for example, that typically done anyway.
Yes. Yeah. Any other questions? Yes.
Not a question, but just a suggestion. As a result of your speech, obviously, not many people will be developing some of the tools to monitor, or if not already developed. And if some of those learnings can be put in the developers community to share with others, that would be a real great help for everybody.
Yeah. Yes. What I'm actually building tools into an application does depend on the application. It's not easy to just say, oh, just here's a framework, because different people have different ways of building their framework. What I am doing at the moment is trying to specify a generalization of the tools that we have in TrackCare so we can drag those down into the data platform layer, learn from that information. And hopefully that's going to happen at some point in the not too distant future. But I'd be very happy to talk to anyone and work with people about techniques for building monitoring tools. It's not difficult, it's not rocket science. It's just there are things to beware of if you do that, and techniques for rolling stuff up efficiently that you might not have thought about. And I have been thinking about these things, so I'd be very happy to talk to anyone about instrumenting their application and how to go about that. Any other questions? Everyone wants to get to the airport or the pool or the bar. It's 12 o'clock. It's been a good conference. I know there are some sessions after lunch, but thank you for attending this morning. Thank you for coming to the conference.